Welcome to the project demonstration of smart residential electricity management and cutoff system using network based embedded controller. So here the main features of this project is, so we are going to set a threshold value to energy consumption. So based on that energy consumption threshold value reached, then system automatically cut off the power into the load, so in order to prevent the overpower consumption. And the same, we are going to upload the data to the ThinkSpeak using embedded IoT platform using the ESP8266 Wi-Fi module to the ThinkSpeak cloud platform. This data can be accessed from anywhere in the world. The data consists of kilowatt hour, how much of energy was consumed, and the time also. So just when we click on the dot, we can see the kilowatt hour reading along with the date and time. And next is keep on increasing. Whenever the data is crossed the threshold value, then automatically the supply will be isolated with the help of this electromagnetic relay. And to operate all these input output modules, we are making use of PIC microcontroller, which will control the input and output module. So in our project, input modules are energy meter was interfaced to the microcontroller at pin number A4 through this PC817 optocoupler IC, so which will take the input from the energy meter LED indication, and the pulses will indicate the load status. Nothing much. The pulse duration between the two blinks is less than the heavy load was connected. So if the duration was more, then the low load was connected. As we know that in our houses, so we can see the energy meter, which will one LED will be there, which will indicate the status of the load connected. So when the LED blinks fast, the heavy load was connected to that, and the blinking slow, there is low load was connected. So the blinking pulses input to the microcontroller through this PC817 optocoupler. So here the purpose of the optocoupler is, whenever we are getting the pulses, instead of giving the pulses directly to the microcontroller, we are providing that to the in optocoupler first starting two pins. There's a primary side and secondary side. So this side will get the pulses, optically coupled IC will provide the same pulses to the output side. So without this, if you provide the directly to the microcontroller, then if is any short circuit occur inside this energy meter, then the microcontroller may get damaged, which is the main brain of our system. So in order to protect the main brain of the system, the microcontroller, we kept a small IC which is isolated between these two. So if any goes wrong, then only the IC may get damaged, just which is easy to replace the IC. And the next, we have provided that, as we discussed, A4 pin, and it will calculate the kWh as energy meter readings will provide us the kWh readings. Nothing but whenever this blinks count reaches to 3200, then the load was connected to this one is kWh of 1000 watts of per hour completed. Means if the light blinking is count keep on going to 3200, that is indicated of till the duration the system consumed the 1 kilowatt hour, means 1000 watts of power was consumed by this load. So if it's 1600, then 500 watts, like that. One blink is equal to 1 by 3200 kilowatt hour. So that is a calculation to get kWh, and that was done in the embedded C language, and after that the data will be displayed on the LCD screen, and same data will be uploaded to the ThinkSpeak with the help of this ESP8266 Wi-Fi module. So the whole system getting power supply from this 230 volts AC inputs, and that will be parallelly distributed to the energy meter as an input, and also to this regulated power supply board, which will take 230 volts AC input and provide us the 5 volts DC output to this wires, and that is the main operating voltage to our microcontroller. So it will start reading input from the input module, and once it crosses the 0.004 kilowatt hour, then the system will cut off the power to the load by using this electromagnetic relay. We have interfaced that pin number C7, A4 for the optocoupler, C7 for the relay, B0, B1 for the ESP8266, B2 to B7 for this LCD screen. So let us see the demonstration. So before demonstration, first of all we need to on the hotspot. So for that, go to hotspot settings of your phone and configure the hotspot name to project 7101, and the password should be 123456789. AP band should be 2.4 gigahertz. So after configuring this all hotspot settings, on the hotspot along with data, and log into the ThinkSpeak cloud platform. So there we get the page. This is our channel. Open that. So this is the old data while we are testing the project. So it will display the kilowatt hour along with the billing details, how much of bill was generated at respected time. So if you want to get the fresh data, or if you want to erase the old data, or if you want to download the data also, you can do that. But before erasing the data, we should get the backup. So for that, data import export, download the data, open. So it will be open Excel sheet. So that consists of date and time along with the number of samples till now collected and the field 1, field 2. Field 1 is the KWH and field 2 is the billing details in rupees. Okay, total 4 samples till now will collected. So after we took the backup, now go to channel settings. In that, only do clear channel. So once channel got cleared, now go to private view. There you get old data got erased. Now you can on the cache. So no need to erase also. You can keep the old data as it is, but hotspot along with data must and should important. Now once initialization successfully done, the light will be on and off. Then the relay will get switched on. So on LCD we can see that. So on LCD we can see that. As we discussed, one blink is equal to 1 by 3200 kWh. So it will be added, keep on whenever the blink is coming from the energy meter through this optocoupler IC to the microcontroller. So whenever it crosses the 0.04 above the kilowatt hour, then automatically the system will isolate the power supply to the load by controlling the relay. So meanwhile, you can see the data is keep on uploading to this. The data uploading rate to the ThinkSpeak is around 10 to 15 seconds of duration. It will get uploaded and there will be presented graphical presentation on this page. So it's the KWH as well as billing details. Right, we got the another data. And once it crosses the threshold value, once the cutoff successfully done, then in order to again resume the power supply to the load, we need to reset the microcontroller just by pressing the reset switch. So we'll show you that. Right, it crosses the 0.04, then automatically it will cut off, and just to resume the power again, just you can reset the system. Right, again same process is going on. Calculation of KWH along with bill calculation and uploading the data to the ThinkSpeak.